you see Paris, London, financial capital, or what used to be the financial capital, connecting to New York. And then you see the South America waking up with light, with the day coming.
Well, it's very beautiful.
Thanks, Bruno. Yeah. And here you see like Asia falling asleep, going to sleep. You know, by doing this, and look at Africa, it's quite impressive actually. Very little information. We just took the top 300 cities, and there's only one spot in Africa. And you see Australia, the main hubs. Then you can go back to the States. It looked a little bit like the States bombing everybody. So it was still the Bush time, so it was a bit dangerous. But every dot was actually a megabyte being, a gigabyte being transferred. So, you can do this, but the interesting thing is that then you can analyze this data. So, and here is something that we do, and it's quite unique to the way we're doing research in our lab, is that we try to make a statement or a vision or an intervention in the city. And this is what has like, what ends up in an art museum. It's at MoMA, it's at the Biennale, it's a design museum in Barcelona. It's a way to actually inspire people, to show a possible scenario. So that's one side. But then on the back of that, you actually have a lot of mathematics and physics and analysis and electrical engineering. You've got all the research, the actual academic papers being written. Could be in sociology, in the analysis, or in electrical engineering, but all of that stuff to make it possible and to see the consequences of the exhibition. So now there's actually three, four PhD students working on this data. Here, analyzing all of this, how it changes over time. We think that the mapping is crucial. So actually in the mapping, I'll show some of this on the mapping on Saturday at the conference. For instance, by very simple ways, you can understand a lot about the data, not only with the analysis. There's so much data today that the mapping can help you really narrow it down. Remember, it was discussed a little bit before, but remember that story by Borges that's about a cartographer. And the king tells the cartographer, go and make a map of the kingdom scale 1 to 1. And the cartographer goes, and by little, the kingdom and the map become the same thing in 1 to 1. Well, today we're doing something like that. We're doing scale 10 to 1, 100 to 1. We're adding all this digital information onto physical space. And so the actual act of mapping them, of narrowing down this information, can help us understand some of the things that are much more difficult to visualize just with pure mathematics or physics or formulas. So we use a lot of this. In the case of New York, we also looked at what happens inside the city. So here you see Manhattan, the Bronx, Queens, Brooklyn, Staten Island. And you see how coal originating here, this spread onto the world. It's like looking at the DNA of every bit of the city, and how, how much of South America you have here in the Bronx, for instance, compared to look at Manhattan talks really much more with the rich parts of the city, of the world. And you can analyze this. You got bit by bit, pixel by pixel, all the top cities. It's like a census in real time. Census used to happen every 10 years, and it takes a lot of time to analyze the data. And it's like a census in real time. And you can zoom in and see what happens there. I will skip it. There's really a lot of mathematics we're doing on this. We've got a number of people analyzing the network, doing network analysis with geography. This is some of the first results is about an interesting superlinear feature we found. But again, I'll talk about this on Saturday. I will not go into detail. I'm from MIT, so I need a slide with formulas. So here it is, but I think we can skip it. I'll show you now another project. So what we saw today so far was 2 projects related to using networks as a way to capture and describe our space. Now, there's a beautiful thing that's happening today, is that a lot of this digital information is not only centralized. AT&T is a centralized system. So if you want to do the project like the MoMA, you go to AT&T and you say, well, I want to do this at the Museum of Modern Art, and would you give me anonymized data? They think about it and they give it to you. But the beautiful thing today is that there's a lot of data that's actually free, that everybody of us is actually uploading onto the internet. And among this data, for instance, is pictures. Humanity never took as many pictures as we are doing now. And a lot of these pictures are being uploaded to databases like Flickr, and a lot of them are geo-referenced, and a lot of them are actually tagged, and you know who took it, when it was taken, and so on. So if you do a little script, you can actually browse this big repository that's free and open for everybody, for whoever wants to share their picture. And so we started doing some project in Florence for this. Florence is also one of the partners of our lab. We do work with cities. Hopefully we'll do some projects with Paris, actually, also with Bruno soon. In here you see, for instance, the density of pictures being taken by tourists. If you take all of northern Italy, you see it here, and then you zoom into the city, into Florence, and you see the main highlights, the main hotspots where people take pictures, and then you zoom into the church, actually, the Duomo, and you see exactly where things have been geo-referenced. If you add a little script, look at the time of the picture was taken, you can actually do traces. And look at this, actually. That's the difference between Americans and Italians. So where do you think Americans are? Well, Americans are to the left, you know, where they have this sort of elephant's path. Then they go to Italy and they see those 5 things and they just move between those things, which is, it's reasonable. The fact that if you come from the US and you go for a week to Italy, you go to the main places there. Well, look at how differently Italian move in Tuscany. You know, look at this little island called Elba, where there's nobody, no Americans ever on Flickr took a picture of Elba, but all Italians actually go. It's something that's not very international, but very, very local. The idea that, you know, the difference in behavior and movement onto the space. We got an exhibition now on this project, on a similar project at the Design Museum in Barcelona. It's on now. I will not show you the videos. They are online if you're interested on our website. I will just tell you there is a very deep scientific question that one of the kids in our group is examining, is correlating the geography of Britons and parties in downtown Barcelona, if there's any possible correlation between the two geographies. Right, so sometimes, you saw before, we look at sensors. So the next 2 projects will look at how new type of sensing technology can help us describe the city in a new way. And these are 2 projects we're doing this year, one in Copenhagen, one in New York. Both cities are partners of the lab. I'll start with Copenhagen. Copenhagen, this year, at the end of the year, there will be a big conference. It's called COP15, and that's where the Kyoto Protocol will be rewritten. And it's about climate change. So the mayor of Copenhagen came to us and said, what can we do with sensing and digital technology to make the city, or to promote and highlight sustainability? Now, Copenhagen is an interesting city because of this. 20 years ago, very little bicycles in the city. Everybody really wanted to have a car. And then if you go to Copenhagen today, like 40%, 35 to 40% of every trip, every day, is done by bicycle. You know, they got even biking congestion, traffic jams, and yeah, it's interesting. And something, you know, this is a typical picture. Great city. And so we started thinking, how can we use the cities as a way to sense the environment? So we decided to build a wheel. We call it a green wheel. So when you brake, when you stop, or when you go downhill, this wheel will actually reuse the energy, that the kinetic energy. So we'll transform it into electric energy. It's a little bit like in the hybrid vehicles. When you brake, you save that energy. And then we say, well, with this energy, what do you do? Well, of course, you can use it when you need extra power. So if you go uphill or if you need to start. But basically use it for powering sensors on the wheel. So the wheel become almost like alive. So what type of sensor would you put? The first one we decided was something to monitor air quality, so particulate. We found the way to do particulate in a very, very simple way with a laser. So you monitor your exposure to particulate while you're driving in the city, cycling in the city. And you also share this information with the city council. So the city council automatically has like a network that has all this information in real time about what's happening there, about air quality. The second thing is actually the bicycle has a torque measurement system. So it becomes like, the wheel becomes a little bit like your personal trainer. So one day the wheel could tell you, Bruno, I mean, your torque today is not as good as it used to be. Maybe you need to go and have a checkup or something. And that's fitness reading. And then the third thing is also has locationing. And through locationing, it allows you to do a number of